Again, no individual question through the whole class. That's why I grade them one question at a time to make sure. Some of the questions were very, very straightforward. Some of the questions required a little more emphasis on like critical thinking. The one that I'd say through maybe 15% of you, which is by no means a plurality, no, it's a plurality, I guess, it's by no means a majority, is interpret the value of the standard deviation. Most of you got it right, I think. I'm pretty sure based on what I read. You gotta tell me what the standard, this is for the number of eggs my chickens were laying. You gotta tell me what the 1 means. Some folks just put x bar equals 3, s equals 1. Like, I know that. You told me that 1 question or 2 questions before in Excel. But what does the 1 mean? And then some people said, well, 68% are within 1 standard deviation of the mean. I'm like, what? That's only if the data's bell-shaped. We haven't talked about that yet. What does the standard deviation always mean? It's the average distance from the average. So as long as you got that idea across in your answer, I was a happy guy. On average, my chickens were laying about 1 egg away from 3 on any given day. As long as you got the on average, it's the distance away from average, I was a happy guy. That's what I was looking for. But that's the only one, and I'm not even going to say that it threw most people for a loop, because it didn't. Most of you got it, from what I remember. So I was stoked there. So, speaking of stoked, am I stoked based on this? No. Tell me why no.
It's not a very, I don't know, it just makes me...
It's not a bell curve.
It's not a bell curve.
It's not a bell curve. Would I want this to be a bell curve?
No.
Would that make me happy? If it were a bell curve, what would be in the middle? This is kind of hard to see. I apologize for the scale. -5, 105. What would be roughly in the middle? 60, 50. On average, you'd have a hump at 50 and 60. I don't want most of you getting 50s and 60s on this. So, I like what you're saying, Jen, in that it makes you a little bit squirrely inside, because you're like, it's squirrely because it's not a bell curve. We talk about bell curves a lot. Okay, well, you can kind of pretend it's a bell curve if you want to, and call the center right here if you want to do that. But it technically ends at 100. I know it says 105. It's one of those scale things, histogram scale things. So I don't want a bell curve. I don't want to be like that movie Flatliners, where I walk in on the day of an exam and I collect all the exams for you guys, and I say, okay, there will be 1A, 1F, 5 Ds, 5 Bs, and the rest of you are going to get Cs. Because that would be forcing a bell curve onto the scores. I don't want a bell curve. I want this. This makes me stoked, because these are the good grades, the 100s and the 90s and the 80s, and it does this. Right? It does that. That's why I'm stoked. I'm stoked in its skewness. See that skew? Now, if you didn't do, and this is totally fine if you didn't do the variation extra resource pages that were on there, in there I actually talk about the Pearson second skew coefficient. We've been using the phrase skew in this class. Talk about things that aren't bell curve. If they're not bell-shaped, they're skewed. A bunch of you use the term correctly on the exam. Why are trim means sometimes used? We use trim means sometimes to remove outliers that might skew the average. Hell yeah, that was great, perfect. But then the question becomes, hopefully you've been thinking about this, how skewed is too skewed? Yes? How skewed is too skewed? Like, when does it not look like a bell curve? It's pretty obvious, not a bell curve. But like, what if it looked more like this? Could you call that a bell curve? And again, it becomes a bit of gray, but maybe it is, maybe it isn't. What this measurement actually allows you to do is to quantify the skew. And that extra resources page shows you how to actually quantify the skew based on the data. So yeah, the fact that it's not a bell curve makes me happy. Good. Tell me something else that's interesting about this. Just a quick breakdown. Mu is the class average. I called you mu instead of x bar because you're my 243s. I called you my population. Population average, 5% trimmed population average. Population standard deviation, little sigma versus little s. Median, mode. I invented this statistic. I thought it was kind of fun. Rather than just telling you what the mode is, which is nice. Good nice. That's been a new word. Good nice. It's nice. I told you what percent of the class got that grade, which is, I think, even more telling than just knowing what the mode. The mode's a 97. Well, that could be that 2 people got a 97, everybody else got individual grades. That would be a mode, right? But this tells me that 13%, roughly 1 in 8 people, got a 97-ish. Exactly. That's kind of like, it's more descriptive, isn't it? The skew, -3.5. So tell me some interesting stuff about what happened. Quantify it even further. Use the box plot down there. You know what a box plot is now. Sean, go!
I find it interesting that the mode, meaning 97, is in the top 25%
Isn't that interesting? Which is one of the reasons I argue that the mode is often ignored, because it's kind of fluky as to where it goes. If I had 4 people or 5 people not turn the exam in, the 0 could have easily been in the mode and not changed this much at all. Yeah, did you hear what Sean said? The mode's 97. And he caught that that's within the top 25% of scores. See that? How did he know it's in the top 25% of scores? How did he get that? Because of this, what is this called down here? Good, box and whisker, box plot. It's got a couple different names, box and whisker or box plot. What's nice about it is it breaks up your guys' data into 4 regions. Bottom 25%, next 25, next 25, next 25. So 25% of you got a 96 to 100. 25% of you got a 92 to 100. Well, hell, the median's 92. That means half their class did better than 92. Well, hell yeah! Again, this is my hell yeah. This is why this graph makes me happy. Now, and this inevitably happens. This inevitably happens in my classes. It tends to be skewed right, or I think this is actually called skewed left because it's negative. It's skewed, highly skewed. And the left half of the data tends to be much more varied than the right half. Why? I can't explain. I don't know why. It just ends up being that way. Lydia, please.
I'm a little confused about the graph. Why does it go from -5 to 105?
Because, very good question, Lydia. Remember how in the TIs when we're making histograms, when we set X max, we often have to go one past what the true max is to make the bar show up? It's because the programs that are used to make histograms assume continuous, not discrete data. So since I couldn't make a dot plot for this and put dots above 100, I had to give it ranges. And the way this one's set up, I tried to go 0 to 100. And when I did that, it said certain data will be excluded, namely the 0s and the 100s. So I had to make them go 2 extra bars, one going from -5 to 0, and one going from 100 to 105 to include the 100s and the 0s. Why? It's just the way they're set up to graph data. I don't have a better answer to that, unfortunately. So, if I can make a dot plot, which I'm working on customizing a dot plot, it would take care of that. So just realize, this is -5 to 0, 0 to, no, excuse me. I think that's right. It might be -5 to 5, I'm not entirely sure. -5, 5, 15, 25, 35, 45, 55, 65, 75, 85, 95, 100. I think that's what it is. There are 10 wide each. So, I don't have a good answer other than that. Just because that's how the program is set up to work. Yeah, Kel?
I have a question, and I'm sure you've probably told us, I just can't remember. Why isn't that little box represented on the bottom?
It is. It's an outlier.
I didn't see it.
It's okay. That's good. It's an outlier. Remember the definition of an outlier? No, you don't, because we haven't done it yet. We keep talking about it, right? We keep talking about outliers. What is an outlier? What is an outlier? We're going to define it today. That's the point of today, is to get into how do statisticians quantify outliers. You guys were all using the term correctly on the exam. You were saying trimmed means knock off outliers, which gives you a more, some of you guys use words like resistant, or a more, you used resistant, you used, some of the words you used were fantastic, like a resistant measure of center, a truer measure of center. I did pick on you a little bit. Like if somebody just put, why do you use a trim mean? To get a better average. I'm like, define better. Like if you mention the thing about outliers and throwing away skewed-ish data points, I'm like, okay, you understand. But you can't just tell me it's a better mean without telling me why it's better. Does that make sense? So you have an intuitive feel, I think, for what outliers are. I want to kind of firm it up today with some data. We'll play with that with some data. So that's the best. He's right there. Yeah, and the problem is, Kelly, this is unfortunate. Again, I'm working on fixes for this. There can be more than one of these, and in my opinion, they should stack them to show that there are more than one.
Yeah.
But they just don't. There could be multiple, and I don't have an N sample size here. I wish I had done that. I'll do that next time. Yeah, anyway, that's where that box is. Now, what I'd love to do is put this on top of that, like your TIs do, but again, the program I'm using doesn't allow me to do that right now. So, good work with finding the graphs from the news that were misleading versus not misleading. Actually, you had to find ones that were misleading, right?
Yes.
Because National Geographic was okay. Wasn't that cool? I feel like there were 1 or 2 of you that used words like diameter and things like that in the National Geographic one, and I feel like I should have guided you a little bit better. There were no circles, so there were no diameters, but you got the point across, is that the areas of the chicken and the duck were proportional to the numbers of the chicken and the duck. That was the whole point. That was the whole point. And very often they're not, but National Geographic did a really good job of that, I think. Trey, yeah?
said or you wrote, remind me to tell you about this.
Oh, the one you used, Marty stole from me. You got that out of Triolo's book,
Yeah,
right? Marty went and saw a conference I presented at, and I used that graphic, and he thanked me after. He's like, thanks for that awesome idea for a graphic. 2 years later, it shows up in his book. I'm like, you son of a bitch. Marty, I'm watching you. No royalties on that one, buddy. No, it's just, that's all that was.
Okay.
It's just, I recognized it. I'm like, yeah, that's my graph. It was the feeding tube. It was the Terry Schiavo case from Jersey, which you guys probably don't remember because you're either A, too young or B, too West Coast. There was a woman in Jersey with a feeding tube attached to her, and she was brain dead. She was, I mean, everything was dead except for the fact the feeding tube was in her belly. And there was this long, drawn-out legal battle with whether we should pull the feeding tube out, because the only thing keeping her alive were the machines at that point. They eventually pulled the tube, but it caused this media uproar, and that graphic was a representation of piss-poor explanation of how to show that liberals were more liberal than conservatives. The percentage difference was something like, what, 7% difference between liberals and conservatives?
Yeah.
But it looked vastly different because they chopped the horizontal, the vertical axis.
Started at 54 instead of starting at 0.
They started at 54 instead of starting at 0, which exaggerated the difference. But most people in this class, it was awesome, found graphs that chopped the vertical axis and exaggerated differences. Good for you guys. Good for you for noticing them out there. And the ones that didn't find those found other interesting things. So, I loved your responses to how many eggs do I get for my chickens on average? Did anybody get freaked out by that? Oh my God, oh my God, oh, right. You write anything. You write what you would tell my neighbors if you got asked that question based on your data analysis. Some of you just said on average I get 3. Some of you said it depends on the time of year. Some of you said, what? I don't have chickens. But that was the whole idea, was that, you know, there's so much gray loaded into these courses, into the course of statistics and the subject of statistics. I'm teaching you how to kind of quantify the gray. And I'm not saying there's one correct way to do it. I mean, Jen, some people could look at that and say, yeah, I think it's arguably bell-shaped.
You know, if I had read that as your exam scores, I probably would have said that.
Oh, sister, it's all good. It's all good. It's totally fine. But don't, just because we're talking about bell curves and because bell curves do pop up, doesn't mean they're everywhere.
Okay, no.
I would hope they're not everywhere all the time. I mean, otherwise everything's 50% all the time. I don't know if I want you guys averaging 50%. I'd rather have you. Did you catch the difference in the average and the median? 6-point difference? And it's very different in the mode. But again, the reason is, who is affected by outliers? Who's affected more by outliers? The average gets pulled towards those outliers. The median goes, it's just down there on the end. He's just the same as one up here on this end. He doesn't care about how far down on the end, just that it's there versus there. For the trim mean. So, I was tickled. I was stoked. So, next question, just like in 105, we have what's called a rainy day coupon, which I had hidden from you guys. I apologize. I didn't have a very good link on the schedule page. I thought I did. Actually, I did last term. It was much more obvious last term, and for some reason it got lost. Anyway, if you go to the schedule page, I will show you where it is now. I sent you a note yesterday about this. But if you go to the schedule page that you know and love, there you go. Now you'll notice a new big yellow box. Pow! Rainy day coupons right in the middle. There are 3 of them. Lydia, what you got?
I've been able to see that the whole time.
It was there the whole time, but it was kind of buried down in week 3. It had a link, but it was just very small. And I don't know what the hell happened. I had this box up last term, and then for some reason the line of code got erased. I don't know why. But anyway, I put it back. So when you click on it now, let's make sure we understand what all these are. The first one is for projects. You have a project coming up. Next class.
Yep.
Joint probability. Probability part the second. Yes. Don't wait until Wednesday night at midnight to start it. The math is not difficult. The reading might be. It might take you all to read through and understand what the hell I'm getting at. We're talking about Max and pumpkins. We're talking about race and apartment complexes. We're talking about germination rates of seeds. It might take you all to kind of process all that. Don't wait till midnight, Wednesday night, or Thursday morning to start it. Okay, anyway, but suppose you do. And you walk in here Thursday, bleary-eyed, not enough coffee in the world to keep you awake. This allows you to work 24 hours on one project. If you forget to do a project, it buys you 24 extra hours to get a project done. So if you do come in Thursday without that project, you could submit it Friday with the coupon stapled to it under my door, if you can't find me, under my door in the office before 10:15 on Friday a.m., no penalty. The only penalty is, you may have noticed you guys all have 5 extra credit points right now. If you look at your progress reports, at the bottom there's an extra credit points section. One says, they say? One says, well, they say something, something, and project. Project, rated 8 points is what it is, rated 8 points, rated 8 project. Rated. So the rated 8 project, this is worth 5 points if you don't use it. So right now, it's extra 5 points. So if you need 5 points added on to one of your quizzes or something, just go ahead and throw it on there. If you want to make you feel better. If you want to make your 100 or 105, go ahead and do it. Because you can, that's what it's worth. But as soon as you use the coupon, that 5 points goes away. So it's my saying thank you for getting your stuff in on time. And check out the whole deadline I did. Good.
Is that already calculated into our grade?
Yes, ma'am.
Okay.
That's why so many of you had 150% in the first week of class. Because you turned in a 10-point quiz, got a 10 on it, and you had 5 extra credit points, which means you had 15 out of 10 points, which is 1.5. Extra percentage is 150%. Now that 5 points is less and less of a percent as the term goes on, and by now it's almost incalculably small. But it's still your points. You can keep them as long as you don't use that coupon. This and this they don't have any cash value unless you use them. So it's different than a project coupon. So this one, when I say you can make corrections on your exam, you can get up to 5 points back on the exam you just got back. But you have to read this and do everything it tells you to do. You've got to print this thing out and attach it to your original exam. Then you've got to do corrections on a separate piece of paper. Not on the original, because I like to look at the original and your corrections, compare, contrast, A, B, if you will. In further addition, you must write a sentence explaining the mistakes you made on every problem you made the first time. In further addition, you must also write a sentence describing what you learned by doing it a second time correctly without the stresses of whatever stressed you the first time. In further addition, the corrections must be correct. I had to add that. Students were turning in wrong work, demanding points. I said, what are you talking about? They said, it doesn't say it has to be correct. Like, it's called a correction. They said, it doesn't say it has to be correct. I'm like, future lawyers of America. Thank you. So I added the line, corrections must be correct. Please, Lydia.
So it's only for exam 1?
It is, because exam 2, you're going to hand it on the last day. I'm not going to see you again. Unless you're going to come back in June and drop it off. Which I figure you don't want to do. So, but because I used to give 3 exams, so there were 2 rated A coupons, one for exam 1, one for exam 2. Instead, I made a rated A quiz coupon, which is similar. It allows you to take any one quiz that you tanked and resubmit it to get a 10 on it. So suppose you get a quiz, and most students will save this until week 10 and then turn it in then, once all their quizzes are back to them. And then they go through their quizzes and go like, oh look, I got a 3 on this one. Let me resubmit that quiz and get 7 points back. So this is kind of like the other exam coupon now. Does that make sense? Yeah, this will be able to, you fix that other exam. And it's got to be an exam that you already submitted and got graded and handed back to you. You can't just like go back and do one you haven't even done before. It's got to be a correction. The idea of it is a reassessment of learning. And that's the whole point of all of these, except for this. This is just to get a jail-free card. The whole point of these is just to make sure that you can go back at an assessment, look at it again, and get more from it, maybe. Get more out of it. Oh, and there's something else I'm supposed to give you. Oh, but I can't. So here, these are the quizzes you guys did in class last time. Your grades are in your progress report if you did them, but I don't know how to give them to you because there are more than one person's name on them, so I'm going to leave them here. You grab a break. Okay? And this is all old stuff. Okay! I think that's it as far as this stuff goes. Please, Sheila.
What was the extra credit point on the exam?
A bunch of you got it. Very, very good. So there was a statement that I put. After all, it is 2013, and then a footnote, and I said, and I don't mean. What was that? Those of you that got it.
So you just scroll down infinitely down on the left of the B column, or like the column on the left.
Column.
If you just scroll down the page, it goes from 1 to 100,000.
Hang on one second, Zach. Let me take a look at that. I'm not quite following, but that's okay. So here's the exam. There it is.
If you're looking at your Excel page, you can just scroll down infinitely, as opposed to say, look at the bottom. There's 3 tabs.
Yes.
But you gotta go to Excel to see what I'm talking about.
I will, because I don't know what you're talking about. I do want to know what you're talking about, because that's not. You open? Chickens? All right, girl. So you're saying go to moving average.
Go scoot to the left a little bit because you're blocking what I'm trying to talk about.
I'm all the way left. You mean right?
Just bring up a new spreadsheet, I think.
Oh, okay.
No, you can't see the column
You
we're
can't see
talking
it.
about.
Oh, I'm sorry. It's the damn. Okay, so I'll just do this.
Right, so if you keep going down and down, there's like random numbers forever.
Random
Yes, well, Excel is an infinite program. I mean, you could have.
Well, you can top it out though. Eventually you'll run out
Write
of
out
room.
those
Okay.
numbers.
Oh, no, you're overthinking it, brother. Okay, now I understand what you're talking about, and I can say that you're overthinking. So, thank you. Thank you for explaining. I was like, where's he going with this? So a few of you got this.
Factorial.
Yeah, now you haven't learned it yet, but you will. The exclamation point mathematically actually has a meaning. Now you wouldn't have known this right now, which is why it was an extra credit point. When you put an exclamation point after a number, it has a mathematical meaning. It's called a factorial. You'll learn it in your third project. If you want to look at it now, you can too. What it means is start with that number, then multiply by one integer down, and then one more down, and then more, and keep going until you get to 1. So this thing you're looking at is 2013 times 2012 times 2011 times 2010, blah, 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 times 3 times 2 times 1. Done. It has wonderful applications in number theory and number 10. We hinted upon it a little bit in 105, it's smidge. We started getting into that one project, a little tiny bit, not much. But there you go, that's all it is. It's a ridiculous multiplication of 2013 down to 1.
What's the reason for, when would you need, why would you?
Can you hold that thought?
Oh.
Because in turn, it'll make a lot of sense. I typed it, I'm like, oh, this is fun. I'll just add this to them.
Did you really waste the time to type it?
No, I copied and pasted it from a big, I Googled big number calculator
Oh, okay.
and put it in and then just copied and pasted it and then made
Oh, I was gonna say, if you type that in,
Oh,
oh man.
sweet Jesus, Omar. No, God, no. I had to pick the font right to make it all fit.
Yeah.
And that's just one of those ridiculous little numbers, like a Google or something along those lines. Good, no. And it wouldn't be time wasted, it would just be time ill spent. Cool, everybody happy with this? Content? Making sense? Hopefully. If you have other questions, grab me a break. Let's get back in here. What I want to do now, here we are. Yes. What I want to do now, yes. Let's begin the next little pie. What's neat about today is it's